This is the fifth grade science open house. The purpose of this open house is to give you an idea of what the fall fifth grade science course looks like. So I'm going to be using some materials from the summer course to give you a sample of what to expect with the lesson. All right, so let's do introductions and then we'll jump into what the class looks like. All right, so first I want to introduce myself to let you know who I am. So I'm Galen Tracy. My students call me Mr. Tracy. As an educator in the Houston area, I worked at a private school for 7 years now, and I taught fifth and sixth grade science. The school that I'm currently at is a GT school, so it's for gifted and talented. So the curriculum's year advanced. So that's a little bit about my employment background. While I was at the school, 2 of those 7 years, I was the lead teacher and the head of the middle school science department, which is a lot of fun. Got to share some technology and resources with other teachers and give them tips on how to improve their lessons. I have a bachelor's degree in general science with teaching from Temple University, which is located in Philadelphia, Pennsylvania. Interesting fact about that is the program called UTeach was originally developed at the University of Texas in Austin. So that was the pilot program, and then it spread to Temple University. So my lessons are very inquiry based, meaning you're doing a lot of activities and exploring the concepts yourself to really learn the material well. So we're practicing science skills and we're connecting what we're learning with the real world. This makes it easier to remember and makes it more interesting. I love using visual and physical models when I'm teaching to make lessons easier to understand for all learning styles. In the course, we use a lot of simulations. So one of the programs I'm going to show you that we use for a lab is called PhET, P-H-E-T. It's a lot of math and science simulations. And what's great is they're all free. So you don't have to have any extra logins or purchase any additional programs to be able to do the labs. So I love learning about technology. Recently, I did a level 3 certification in AI tools, which is great for a teacher because it allows you to create really detailed lessons in a short amount of time. Really helpful tool as an extension. I also coach 2 sports at the school I'm at. That's a little bit about my background. I believe this slide here is showing you what the course offerings are for Momentum Learning, their science curriculum. So these are some of the courses. There's a QR code if you want to pull up a phone to scan it so you can learn more. Right. So I teach currently 3 courses at different times. There was a summer program. We're about to start the fall course, and there's one in the spring as well. That's where I fit in. I believe these are other course offerings that you can take. Right, so you can see some prerequisites for courses. All right, that was about 30. What I'm going to do for you is I am going to share a link in the chat to these slides if you wanted to give them a second look. All right, so let's talk more about the course that I'm the instructor for. So currently, this is the program I'm involved with, fifth grade science. You can see when the fall course starts and ends. So it begins September 11th and runs until December 4th. It's one day a week, Wednesday, 6 to 7:30 Central Time. And then there's a holiday date on the November 27th. So we would not meet on that day. All right, so many of the people enrolled in the fall fifth grade science took the summer one, but I do want to let you know that one of the intentional decisions made with this course is it's intended so that you can join at any time, right? So the courses themselves are independent, right? So you won't feel like you're watching the sequel and you haven't seen the original yet. You'll be able to pick up on it and fit right in, even if you didn't take the summer course. All right, so here's a summary of what the fifth grade course is. So it explores fundamental concepts across various science disciplines, including life science, physical science, and earth science. All right, so a lot of the physical sciences. Students learn about ecosystems and organisms, basic principles of matter and energy, Earth's processes, weather cycles, and the water cycle. We do a lot of virtual labs and simulations to practice applying the skills so that you really remember things. And there's many opportunities to independently explore the lab. Like many of the labs will let you do your own experiments within the lab to explore different variables and how they're related. All right, so here's a more detailed look at what the fall course covers. So we can see overall topic of the fall course is focused on different concepts within physics and physical science. All right, so week 1 and 2, we're going to learn about cells, the basic building block of all living things. Each week, we'll have a virtual lab or a simulation or a practice worksheet to apply what you've learned. I do want to make sure I have enough time to demo the lesson. So I'm not going to read all the bullet points. I'm just going to summarize it. So week 3 and 4, we learn about human body systems. So that would be anatomy and physiology. 5 and 6 is matter and energy and ecosystems. So that's all about how matter and energy move through ecosystems from organism to organism. Week 7 and 8 is on plants and animals and adaptations. So that'll link up to week 9 and 10, which will be more focused on how animals develop adaptations and how living things are classified. And then the final 2 weeks are on traits and heredity, right? So basically how organisms develop unique characteristics and how those are passed down through generations and change. So one thing I do want to let you know is this is a rough outline of what the course will encompass. The exact dates of the lessons are subject to change because what I like to do every 4 weeks or sometimes 2 weeks, if it's a shorter unit, is I like to have students review the concepts using Jeopardy, right? That's the main way that we review the topics. We also do like quiz games just to make sure we're retaining it instead of just moving on to the next topic. All right, so I am going to show you what a real course looks like because I'm going to demonstrate how things are organized, but this is kind of like a snapshot so you can see all of the course materials on Canva are organized by week. So within each week, you'll usually see a warm-up, any handouts such as notes and lab sheets, and then a homework assignment, right? So the main assignment, and really the only one that's for a grade, are the homeworks, which are typically about 30 questions based on the topic and the notes. I try to have students do some practice problems that are similar to those questions so they're prepared for it within the lesson. Right, so the main programs that we use are Zoom for the telecommuting and then Canvas for the course materials. So it says Canvas invite will be sent to students, not parents, about 4 to 5 days before the class starts. Right, so you'll get connected with the online course almost a week ahead of time. So homework needs to be submitted on time and will be updated automatically. So this is kind of cool. in most cases, when you do a homework assignment, you'll immediately know your score after you finish it. And you can see which questions you missed. And during the next session, at the start of class, we would go over the commonly missed questions. All right. So this is the website for Momentum Learning. It's momentumlearning.org. This is the phone number. So it's 281-277-9075. And then this is the email if you want to find out more specific information or you have questions about the program. All right, so let's explore what a typical lesson looks like. So I'm going to show you on the teacher side what my lesson planning looks like. So typically a class begins with a warm-up video introducing the topic that's about 5 to 10 minutes long, which kind of is like a summary of what will be covered during that session, followed by 5 multiple choice questions to make sure everyone's listening, right? So easy, multiple choice, right? So it's going to be same question type as what will be in the homeworks. So I give the class time to think about it, and I call on someone. So there's a lot of participation and discussion within the lesson. So many opportunities to participate in a one-on-one way. Right. So then after we go over the listening questions, the next part would be where we do the formal notes. Right. So I'm a firm believer in that when we're learning science, there has to be some form of note taking because there's a lot of information coming at you, and to retain it, you really need to be doing something with the information. Right. So typically what I do is I allow students to print the notes, and then wherever they want to write it, it could be on loose leaf in a binder. You could get a composition book if you want something more compact. We spend about 15 minutes going over the notes, key vocab words. So let me show you what notes looks like. I try to make it colorful and visual, right? Including key pictures that are essential to understanding the topic. So you can see what it looks like rather than have it completely text-based. All right, so you can see the subtopics within the lesson, which are sometimes organized by essential questions, things that the notes would answer. Vocab words are in bold and color-coded so that they're easier to find. Many of the questions that students answer for the homeworks are vocab based, right? So the notes is really the best resource if you need to review something, right? So in this sample lesson about simple circuits, students learned that a circuit is a closed path along which electrons can flow from and return to an energy source. So basically we have a power supply, right, which provides the electricity. We have a conductive material such as a wire, which carries the electrical current to a device. Then we have something that's powered by it, such as a light bulb would be the most simple example, right? So there's a positive and a negative terminal on batteries. So you probably know that if you put the battery in backwards, it's not going to work, right? So there's a positive and negative terminal. On a D-cell battery, the positive side is the one that kind of looks like a button. The negative terminal is the side that's flat. So then students learn the difference between a closed circuit and an open circuit. So one of the fundamentals of simple circuits is that they only work when there's a closed loop, which is called a closed circuit, right? So basically a continuous uninterrupted path that allows the electrons to flow through it. An open circuit is the opposite. So anytime there is a gap in the loop, the electricity isn't able to flow and the device would turn off as a consequence, right? So many times when we have a light bulb go out, uh, it goes out because the filament breaks. So now there's an open circuit and the electricity can't flow through it. Right. So there's a picture showing closed versus open circuits. Another fundamental device is a switch, right? So obviously, if we have something that we're powering, we want to be able to easily turn it on and off. So what a switch actually does is it creates a gap or closes a gap so that we can cycle between an open circuit, which would not allow the electricity to flow and turn the device off, and a closed circuit where the electricity would flow through and power the device, right? So it's just easier than disconnecting and reconnecting the wires every time you want to use something, right? So students also learn that circuit diagrams are used by engineers to quickly show the components of a circuit, right? So this visual here represents the symbols that are used to represent different parts. So this is called a circuit diagram, right? So you can see it's kind of like a simplified picture, right? So another scientist or engineer could go and build that circuit based on the circuit diagram. So then the next concept would be series versus parallel circuits. So a series circuit is a circuit in which there's one path in which electrons can flow. I usually tie this to um, the old-fashioned retro Christmas lights. So anyone who knows that if one of those bulbs went out, all of them went out. That's because it created an open circuit. Modern Christmas lights use a parallel circuit where there's more than one pathway for the electricity to flow through. That way, if one of the bulbs go out, the others stay on, right? Because there's another path for the electricity, right? They also learn that resistors help to control the amount of electricity that flows through a circuit. You would think about it this way. A light bulb only requires so much electricity. So if you use too much power, it's going to break the bulb, right? So a resistor kind of acts like a dam to slow the amount of electricity that's flowing through the circuit so that it doesn't break a device. Right, so this is just summarizing the main concepts: open versus closed, series versus parallel circuit. Right, so then the next part of the lesson, after the notes, students would practice answering some sample questions based on the notes. So I typically do 10 multiple choice questions just so they know what kind of question to expect when they're completing the homework, right? So the idea is you want it to be similar to the homework so we're prepared for it, because the homework, as you can probably guess, is completed on their own at home after class, right? So you wouldn't have the advantage of asking questions, right? So that's what the practice is for. Right, so then we would go over the solutions with some time for students to think about each question, and then a discussion style of going over the answers rather than me just reading them. So then the next portion of the class period would be about 30 minutes long, and that's usually when we do the lab, right? So in this particular lesson, which represented week 9 of the summer course, we did the FET simple circuit simulation for the lab. So I'm going to show you what the lab sheet looks like. So as I said, right, this is what a course looks like. So you can see we have a warm-up, handouts, which I usually tell students to print ahead of time before the class starts, and then any links to labs. right? So this was the website here that was used for the particular lab. So it's simple, but it allows students to build their own circuits to really intuitively understand them. All right, so I'm going to pull up the lab sheet for this lab. And I'm just going to walk you through some of the questions. Right, so many of these simulations are independently paced. Right, so I go over the most important things to answer and how to approach it. And then students have time within the class period to work on the lab, ask any questions, and then we would go over the solutions afterward. Right, so for this first problem here, there's a couple of things we need to change here. Right, so it says non-contact ammeter. Right, so then it says make a wires only circuit. Drag some wires onto the screen, connect them so they make a continuous loop. Right, so it's basically saying build a circuit with no power source or device and observe what happens. Right, so let's do that. We have our wire here making a closed loop. And just as you can probably guess, nothing happens. The electrons aren't moving because there's no power source, right? So then it says to drag the ammeter over a wire, right, to measure the amps, right, the current, right? So we take our tool here, which needs 2 points of attachment, we connect it, and the data confirms what we observed, that there's no current flowing through the circuit since there's no power source. Right, so then we build a simple circuit, right? So we need a battery, a bulb, and wires, right? So we add a few features here. Power source, there's our battery. A light bulb, so we need a device to power, and then we attach it. And sure enough, now the electrons are flowing. There's the electrical current, and our device is powered. Right, so now it says to measure the current using the ammeter. Right, so we would make a prediction about what we think is going to happen when we connect the meter. And then we go ahead and connect it. And sure enough, there's a current, right? Which is consistent with what we see. We can see the device power, the electrons flowing. So there's a measurable current of 0.9 amps. Right, so then the next part, we add a resistor and we observe the effects, right? So anytime we do a lab like this, even if it doesn't say to, students should make a prediction about what will happen before they test it out, right? So now we add a resistor and we can see the electrons are flowing, but it's a little bit slower. And if you notice, the light rays coming off of the light bulb are shorter, indicating that the light bulb has grown more dim, right? So if we think about the name resistor, right, it kind of makes sense what we're seeing, right? It's resisting the flow of electricity, slowing it down, right? And just to confirm, we can see when we measure the current that now it's about half of what it used to be, right? It used to be 0.9 amps, and now it's only 0.45, right? Which shows students what a resistor does, right? Because it's one thing for us to go over the definition. It's quite another to test it out and to intuitively understand it from doing a lab. So that's the purpose. Okay, so now what we have to do is it wants us to make a circuit with no devices and a power source, right? So we get rid of this, get rid of that, connect it, right? So we can see there's significantly less resistance, which is why the electrons look like they're moving faster, right? We also see heat generated, right? Because there isn't the resistance. They're the same level. All right, so then this would be like the more independent part of it, right? So it's all about conductivity. So there's several different objects which you can include in the circuit. And then we measure the amps, right, to determine whether something is a conductor or a insulator, right? So conductors allow the flow of electricity through them. Insulators resist or prevent the flow of electricity through it, right? So like a good conductor would be like copper. A typical insulator would be like rubber or plastic, right? So then we would select the objects, add them to our circuit, and then observe the effects. What's cool about this one is you can basically build whatever kind of circuit you want, right? So I encourage students after they've followed the procedure, completed all parts of it, to explore it on their own, right? Try to build their own circuit to test a variable, right? Like you might explore what happens if we keep the same power source, but we add multiple bulbs, right? So then students would explore that on their own and see what effect it has. Right, so we can see when we added an additional bulb, the flow of electricity slowed down, the bulbs became dimmer. Right, so that is what a typical lab would look like. So obviously that was the abbreviated version in real time. Like it would be 30 minutes, but we don't have that much time. So then after the lab, there would be an opportunity for students to ask any remaining questions they have. And sometimes, depending on how long the lab runs, I'll allow students to start the homework and ask questions as they go. That way they're able to get some help when they're working on it. Right. So like I said, the homeworks are usually about 30 multiple choice questions. Right. And just because I want to, I'm going to show you what the Jeopardy games look like, because you might be curious how review works in this class. All right, so here's an example of a Jeopardy review, right? So we use this awesome website. It's totally worth it for teachers, called Jeopardy Labs. And what's really cool about this program is it keeps track of the score for us. We can set the number of teams, change the names, and then it marks off the questions that have been answered so far. So let's say we read this question, someone answered it correctly. I add the points, and then they select another one. So we can see it's grayed out now, right? So what's really fun about this is there is another resource I use called CCG Buzz, which is a virtual buzzer, right? So just like a game show, students can buzz in to answer a question, right? And I can see who buzzed in first, right? So the cool thing about this is it works on just about any device. You could take like a cell phone, laptop, iPad, and turn it into a virtual buzzer. All right. So that gives you an idea of what to expect for this course. While I am on the call, does anyone have any questions I can answer? Right, I'm checking the chat here. All right, I'm going to take that as a no. So if you have more questions, you can reach out to Ted or the email that I shared to learn more about the program. And hopefully that gave you an idea of what to expect for fifth grade science for the fall course. All right, thank you everyone for coming out and taking the time to learn more about the program. Hopefully, I will see some of you in the future in the class. Bye, everyone. Have an amazing Labor Day weekend.